A firm intends to move 120 heterogeneous virtual machines and a 10 terabyte NFS file server from an on-premises data center to AWS. The company currently maintains a 10 gigabits per second AWS Direct Connect link to its virtual private cloud. Which migration approach provides the shortest total migration time? Option A, export all virtual machines to Amazon S3. Convert them using VM import-export, and transfer the 10 terabyte NFS data using a physical AWS Snowball Edge device.
Option B. Deploy the AWS Application Migration Service for virtual machine replication and use AWS Data Sync to migrate the NFS storage via the existing Direct Connect link. Option C. Manually rebuild every virtual machine on AWS EC2, install all custom applications, and move the NFS server data using AWS Data Sync over the Direct Connect link to an Amazon FSx for Lustre file system. Option D, migrate both the virtual machine images and NFS server data to physical AWS Snowball Edge devices, upload to Amazon S3, and migrate the NFS data to an Amazon EFS file system.
Consider how these different migration strategies impact the overall timeline. We are looking at the trade-offs between automated replication, manual configuration, and physical data transfer methods. We must weigh the efficiency of leveraging a high-speed dedicated network connection against the logistical overhead involved with physical hardware transport, or the time required for manual environment rebuilds. The goal is to identify the fastest path for moving both virtual machine workloads and large-scale file storage.
In my view, the correct answer is option B. The AWS Application Migration Service, or MGN, is the standard for migrating on-premises virtual machines to AWS because it automates the replication process and minimizes downtime. Since the company has an existing 10 gigabits per second AWS Direct Connect link, using AWS Data Sync to move the file data is significantly faster than relying on physical hardware. A 10 terabyte transfer over that link takes only a few hours, whereas physical device logistics would take days.
Options A and D are less efficient because they require the use of physical migration devices. These devices are useful in low bandwidth scenarios, but they introduce unnecessary delays for shipping and data processing when high-speed connectivity is already available. Option C is also incorrect because manually recreating virtual machines and installing software is highly labor-intensive and prone to errors. This makes it the slowest and most complex migration method, failing to meet the goal of minimizing total time.